So we are going to be working on 9D from the Cambridge Unit 3 and 4 Methods textbook, which is learning about graphs of the derivative function. So it's really about understanding the shape. So just quickly, if we look at this here, this is our graph, and we know if we have less than A, we know our derivative is going to be positive. It's going to be greater than 0. Whereas between A and B, we know it's going to be negative because our line will be going down, our tangent line will be going down. Whereas greater than B, it's going up and will be positive. So that tells you whereabouts it's going to be. Likewise, here and here, at our turning points, our gradient is 0. So that is really going to tell us that if we're looking at it, it's going, if I can basically draw it. So our graph is going to be here. So here is going to be my A because it's right here, and here is going to be my B. So they are going to be the intercepts, not positive, not negative. Now, if I wanted to draw this, so between A and B, we know it's in the negative. So straight away, my graph here is going to be in the negative. Then on the outside here, it's positive. So it's going to continue to be in the positive area. So this would be my graph for my gradient, but I'm thinking about the sign that it's going to be. So from the graph, find the derivative that is greater than 0. So if we're thinking about that we're wanting the derivative to be greater than 0, the first thing we need to be thinking about is what part gives us a gradient that is positive? Well, this part right here, but it can't equal to the turning point, and this part right here is going to give me a gradient that is positive. So those are the parts that I'm caring about when x is less than -1 and when x is greater than 1. So if I look at this again, this graph here, I've got 2 turning points I've marked, and it says determine the sets for the derivative that is greater than 0. So the first thing I'm going to think of for being greater than 0 is I'm looking at 2 parts of it. I'm looking at this part right here in red and this part here because it's going up. So that means it has to be less than 0.27 and it has to be greater than 3.73. On the next part, we'll change color to green. It says less than 0. So for it to be less than 0, it must be going down, my graph. So it's between these 2 points, but not equal to. When it's equal, it is going to be 0 gradient because our tangent is going to be a horizontal line. So horizontal line, apologies, terrible drawing, means there's no gradient. So it must equal to those points. If we're sketching the derivative, the first thing I want us to think about is that part there. The first part is it's going to be less than 0. The next part is the turning point. The gradient will be 0 because it's a horizontal line. And then from the rest of it, we are going to be greater than 0. So I've done arrows to help us visualize it. I can do it in terms of inequalities, but all this is going to be for quadratic is literally going to be a linear relationship in terms of gradient. So, and that's because we know that when x is 2 here, a turning point, my gradient is 0. Then the other part that I know here is that from anything greater than 2, it will be in the positive area, which is this part here is positive. Anything less than 2 is in the negative part of the y. So if I've got the f of x is equal to 2x plus 2, we know the gradient here is just going to be 2. So based on this, I can just draw a horizontal line, it doesn't matter what part I am dealing with, it's going to remain this.